Hi, I'm Ben. I'm talking to you today about microservices, REST, and other regrettable decisions. Before I begin, I want to have a quick aside to talk about something that I think is affecting me and probably almost everyone in this room. It's a terrible affliction that I'm calling programmeritis. It's an unending desire to prove you and the decisions that you have made are right in the face of every other possible solution in the space of all solutions. I think this happens because we have our self-worth caught up in the subjective idea stuff. The only way that we can prove that our ideas are any good is if we kind of shit on every other possible idea out there, right? Like, Clojure is really good, and the only way I can prove that is by shitting on every other, like Haskell, Scala, object orientation, that they're all terrible. And I think this is something that we are all very guilty of as programmers, and I am very wary of myself. And I bring this up because I think there's a possibility that this talk could be microservices considered harmful, but I don't want that to be the takeaway of this talk. Microservices is a design that I used to support, or specifically in the way that I'm doing it right now. It is a design that I used to support, and it's something that I've implemented a bunch of times, and I have certain regrets about the way that I implemented it. And I really hope that this information is useful for all of you, as it has been for me as I've been learning through this. So let's start with the nitty-gritty. What do I mean by microservices and REST? So microservices with a RESTful state of mind. First of all, what's REST? You probably have a good idea in your mind that REST is a certain representational state transfer system. I'm not going to be very strict in my definition of REST here. If you have resources, if you have an HTTP API with CRUD-like semantics where you can create, read, update, and delete, whether or not you're using post, get, patch, and delete properly, I'm going to say that's kind of a RESTful API for my purposes. If you've got a Swagger UI page, you've almost certainly got a REST service. Microservices are something that we're probably all aware of from all of the hype that existed a couple of years ago. They are a set of services that you can distribute your application over. What micro means is a hot topic of dispute, but I'm going to take James Lewis and Martin Fowler's idea of built around business capabilities. Usually that means one entity, such as accounts, devices, orders, so on. Each must be independently deployable without any kind of central management. And as an aside, something that's out of scope for this talk is anything regarding operational difficulty of microservices. Maybe you're going, okay, I have a monolith and I don't know if it's ready or not to turn this into microservices, or maybe we don't need microservices. That's not the topic of this talk today. I'm going to concentrate on what makes this system architecture complex or simple from the perspective that I understand it. So to kind of give an example of a microservices system, here's a very simplified architecture of a web shop. Now, it's not necessarily the best way of doing this or like the most common way or what have you, but I think this is something that I've done multiple times, and it kind of looks like this, right? You have some kind of front end at the front, and there's some person wants to buy the latest Hello Kitty notebook. So they go and talk to the API, and the API has an API gateway, which is dispatching over to different services. And those services tend to control different business entities. So we're going to have an account. The account has users, it has emails, it has all of the things you need to be able to log in and track things about that user. The accounts have a basket associated with them, which is what they currently want to buy. And they've had previous sets of orders and orders that are currently in progress, which you can create and delete and so on. All of those need to talk with some kind of inventory to get what is possible to buy. So this is kind of, I think, the archetype of a microservices architecture. You would typically see something like this, more or less complex in lots of situations. One thing to note is that each one of these services can be written in a different language. Each one of them is got what is called polyglot persistence, which is that you have a different kind of database depending on your needs for that service. And that's a really nice thing about microservices. And that kind of starts answering the question, like, why do we start going to microservices in the first place? What was the whole impetus there? when that started being like the greatest new thing. So to an extent, a large amount of it, I think, is a backlash against the monolith, which is the microservices way of kind of shitting on what came before, you know, like, oh, there was that kind of spaghetti code and all of this complexity involved in some kind of, you know, and we will deal with that. And we can make this all simple by having really simple services. And the services are simple, right? You can usually, like, you have a bus factor of 1 on that service. It doesn't matter because you can write it tomorrow. It's just another thing that's storing the amount of user accounts and can probably be done in a weekend. You have enforced modularity. You know, you can't have 2 different services accidentally talking with each other. It's quite an effortful thing to get them talking with each other. So you have this dependency graph is generally better kept, and so you have this module boundaries that you could have in a monolith, but you don't necessarily have, right? You can't guarantee. So that's some of the things, and a lot of people like to talk about scaling too. That's true. You can horizontally scale a particular part of the system without having to change the other part of the system, and that's quite a nice feature of microservices. But as I said, that's not the concentration of my talk today. I'm really interested in how we can decide what is a complex system and what is not a complex system. What is a simple way of doing things? And I think this is something as a Clojure conference we're all quite aware of, right? Like, we all have an idea that complexity and simplicity are important things that we need to deal with, and that's maybe not a unified idea amongst a lot of other people, so that this is our kind of bias here. It's pretty clear that we all think that we know, I think, because of this guy, who gave in 2011 a talk, Simple Made Easy, in which he introduced Clojure and brought Clojure to the forefront to a lot of people's imagination and understanding. I certainly didn't pay any attention to Clojure before seeing this talk. And he dived into what is complexity there. And I'm hoping that I can get something from this talk that I can use to apply to what I want to be able to do in my decisions for making architectures. So what does Hickey answer to what is complexity? Well, he doesn't really define complexity by itself. He mainly concentrates on simple and defining it in opposition to that. So simple is one-fold, so complex must be many folds. You're going to have interleaving logic, and it's going to be really difficult to reason about because you can't necessarily understand that small part without understanding a whole lot of other stuff around it. He also touched on the idea that modularity doesn't solve complexity by itself, which I think is quite relevant to this discussion. A wrapped state is still stateful. But for my purposes, I'm wondering if I can do a little bit better than Rich Hickey for definition of microservices, for complexity, especially since we kind of have a cult of Hickey kind of problem a little bit in this community. And I think it's kind of interesting to go back and look even a bit further back to 2006, when this paper was released, Out of the Tar Pit, by Ben Mosley and Peter Marks. It reads eerily similar to Simple Made Easy. And I'm not saying that there's a direct correlation there, but it does feel like I'm learning a lot of the same things. And it's probably well known amongst a certain set of people here in the Clojure community today. So what is complexity, the Out of the Tar Pit edition? They split it up into a bunch of things. So there's 2 main things they care about. One is state. I think there's no surprises there. Like, we're all aware that state is kind of bad for complexity. The more state that you add to a problem, the higher the combinatorial output to test. The more things you have to keep in your mind at once, so it's harder to informally reason about. And also the more scenarios that you have to kind of run through. Or if x is 1 in this scenario, what happens? And then if x is 2, then what happens? So you really kind of make it difficult to informally reason about a piece of code if you're adding more state. And you have an increase of what's known as bad states. And a bad state is a state that's hard to get out of or is invalid. And if you've ever had to restart a system and you don't know what happened there, then you know what I mean. If you've got lots more states, it's a lot easier for bad states to be hiding in those good states. The other thing that they use to really define what is complexity is control complexity. Now this isn't really touched upon very much in the Clojure community, and I think it might be worth having a look at a bit further. What this is when you order things differently, you get different response, different results. That can be either like it's wrong if you do it the wrong way around, or it could be even that there's a dramatic performance difference. You can imagine a scenario where you filter out something really common first and then do an operation versus doing the operation, then filtering. And we might think as functional programmers we're somewhat immune to this. It's not true. It's definitely the case. Imperative languages have this like built in. If X, then Y, then Z. You have to deal with it there, but you can have it in a purely functional program too. So here's a control complexity example. You have a task, it's urgent, its name is dishes. Then you're going to do a bunch of things to this task depending on certain truthy values or not. So if it's urgent, then we're going to associate the color red. If its name is dishes, then it's absolutely sure that it's not urgent, so we'll remove the urgent tag. And then your final state is something that is color red but not urgent. Now, the order here matters, but it's not maybe immediately obvious when you're reading it that what's happening there, right? It complex your informal reasoning, and you have to work out if it matters. Perhaps it should have been the other way around, and we only should have red things that are urgent by the end, and this is a bug. Perhaps there's an implicit dependency that we didn't realize, or perhaps redness has nothing to do with our informal understanding of urgency here, right? It could be any of the above, but it's all up to the programmer to try and decode. And that's something that you don't need to do if you've got a system which doesn't have order control-based complexity. So that's the second thing that they deal with. And the third thing is, perhaps obviously, how much code you have. And what out of the top it does is argue that how much code you have is more of a derived metric from the other two forms of complexity. So an example of how much code, the code volume metric is cyclomatic complexity, which is how many paths do you have through your program. And if you've got a lot of states, you're going to have more paths. If you've got a lot of control complexity, you're going to have to code around that. So you end up with more code, right? It's not in and of itself a cause of complexity. You can all imagine a one-liner which is very complex, I imagine, I guess, right? The other part, which I think is very important from the Out of the Tar Pit paper, is that they really bring up this concept of accidental complexity. Now, this is in direct response to Fred Brooks's essay, No Silver Bullet, where he brings up the idea that every problem has in its essence a certain amount of complexity, and it doesn't matter what you throw at that problem, you can't reduce it beyond that level of complexity, a sort of Occam's razor for programming. And that's very fair, but they went, okay, but some accidental complexity is our fault. In fact, Rich Hickey in Simple Made Easy has a very nice quote. We chose a tool, it had some inherent complexity in it. It's incidental to the problem. I didn't put the definition in here, but incidental is Latin for your fault. Where incidental, in his case, is what he means by accidental. It's not like, oh, oops, it's an accident. It's something that's not essential to the problem. So I can sum this up in roughly, if the user doesn't know or care about it, it's accidental. That includes every data structure, cool new algorithm, whatever. If you can implement this solution in any possible way that doesn't involve that set of complexity, then it's not part of the essence of that problem. That means, as a weird side effect from that, is that control complexity is almost certainly not essential complexity. If you were to ask a user, if X happens, then Y happens, and Z happens, blah, 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 that doesn't really come into it. You do get the idea of dependency, like this must happen before that, or if in this case, then this, but it's not X, then Y, then Z. For them, that's just not something that's on the level of describing that problem. Okay, but what's this all got to do with microservices? And yeah, it sounds a bit like I've kind of made a diversion now. But I think what this gives us is a nice toolkit to measure up complexity, rather than more hand-wavy measures of, I think this is kind of complex, or there's some state here. I think it's very important to be able to go, yes, this is what is a form of complexity, and yes, is this part of the essential complexity of the problem? And then we can evaluate things from there. So as an example, you can use this toolkit maybe to measure up object-oriented programming. And object-oriented programming is based around objects. Objects are a bit of state with some procedure relating to them. You can set or get those things. You get sequential method calling, or sometimes you even have actor models where the objects are talking with each other. And there's some good things there. You have encapsulation of state, and that's definitely a good thing. Some things that are maybe not so good are you have to represent pretty much everything with state, right? So you're more likely to reach a stateful solution if you're going, okay, I got this new thing to solve, okay, I'll make a new object and that has this method and that method. And so you're more likely to make state that is not in the essence to the problem that you're solving. You're just making a state for the sake of making a state. You're also interleaving, to some extent, business logic with the state logic. So a lot of the business logic is going to be in the methods that are attached to an object, right? So there you kind of want to be saying, like, hey, we've got this essential complexity. It should be separated, I think, from the accidental complexity. So you can tell at a basis, like, this is a part of the problem and I can debug and add features to this. But if it's all kind of interleaved, then that's something you have to deal with as a programmer. And so there's loads of accidental complexity with object-oriented programming. I think to an extent that's fine. We can't really survive without some kind of accidental complexity. It's impossible really for us to make some kind of program which doesn't have something that's not essential to the problem, because computers haven't reached to the point where they can read our minds. But I think the main issue here is that it's kind of interleaved. The accidental complexity is interleaved with the essential complexity. So Out of the Tar Pit came up with their own solution that they thought that is going to solve everything. Maybe they're right. It's called functional relational programming. This is the basics of that architecture. In the bottom right, you have essential state. This is just facts about the system that are inputs to future logic. It's not going to reference anything else. It's all true by itself, and it can never be false. You know, like this is just something that happened. On top of that, you have essential logic. This does all of the different things that you need to be able to calculate a new response or to take new input, and all of the logic that is part of the problem. And you can see there's an arrow between essential logic and essential state. What that means is that if you have to change essential state in some kind of mechanism, you're probably going to have to change the essential logic too. But if you change the essential logic, you probably don't have to change the essential state. And on the side of both of those, you have accidental state and control complexity. And that is something that provides us all the useful things that accidental complexity can give us. For example, caches, different views on things, optimizations from compilers, all of those very useful things that we need to use as a programmer, but not necessarily things that should dictate how we solve our problems. They're not things that should have to change the essential state or the essential logic. They depend on the essential stuff. Great. Some people argue that datomic can be used to solve in such a solution. That maybe. I've not really had any experience of that in production. And maybe your takeaway from this is you're going to use CRUD and event sourcing, and you've got your essential state in the event sourcing log, and then everything is a derived view from that, and that's also possibly a solution. I'm not giving you solutions today. But let's say you're really convinced by this. You implement something really beautiful, and you go, okay, I have a fantastic essential state away from the essential logic, and accidental state away from both of those, and I'm going to use it to implement the ordering system. And I'm going to really rewrite that particular component of our system, and it's going to be really beautiful afterwards. And your boss is really convinced, like, wow, that was so much better now. I give you access to rewrite everything in this essential state complexity. I know this is kind of a far-fetched idea, but let's hang on with me here. So you end up with something that's a bit like this, right? It's very similar to what we saw before, But now you can see that we have a new system for each of those, and perhaps it's Datomic, perhaps it's CQS, who knows. But great, you've got accounts, you've got orders, you've got inventory, you've got basket still, and it's probably not what you wanted. Because yes, you split all those things on a component basis, but what you've not done is considered the system as a whole. And here you've introduced control complexity that's clearly part of the essential logic for the system, right? Like you've got the control complexity between the accounts and the orders, and between everything basically. And each of those services has a RESTful interface which acts as a form of state interpretation. Like, please put this in there, please take that out of that, please give me something. All of those act just like we had for those essential state ideas that we had before, but it's the essential and the accidental is now all mixed up again. So each one of those boxes is split up. But I think a good architecture would have it so that the boxes themselves were these colors. That you had the systems apart from each other and you design like on a whole with the concept in mind of complexity as that. So my conclusion is, work out what your essential complexity is, split on those lines, not on the entities of the system. Try and work out for you what is going to be the way to solve this problem and work from there, rather than go, what are the entities that I need, and expand from that. And when you do so, whenever you make a micro decision change, you should be mindful about the entire system, rather than any small part of the whole. So anyway, my name is Ben. Any questions?